Welcome on welcome online lecture series in wireless mobile communication. In continuation of this equalization, we have another type of equalization, that is the maximum likelihood sequence estimation. Today we have seen maximum maximum likelihood sequence estimation. uh, in the previous, there is a decision feedback equalizer that is not an optimal equalizer because it just outmatches the linear equalization. So if you talk about a DFE, decision feedback equalizer, is not an optimal equalizer optimum equalizer equalizer because because it just that's why the short form of this MLSE, the maximum likelihood sequence estimation, MLSE gives optimum performance performance as it tested all the possible data sequence, previous data, current signals, and choose that data as a output which has the maximum probability to arrive. So This MLSC gives the optimal performance because of as it tests as it tests all the possible data data sequence and choose that data as a output output which has the maximum probability. Means that signal which cannot get affected due to amplitude distortion, or you can say delay distortion, and that is not affected by inter-symbol interference, also the adaptive wide Gaussian noise. They are directly fell on a receiver end. So that probability will be checked by this MLSC, maximum likely sequence estimator. Probability, maximum probability. Perhaps this is MLSC is proposed by the first of all Cornet. I am also preparing for you MCQ questions in 78, in which he set up the basic estimator structure and implement with the Viterbi algorithms. So you can say now you can say that you can say theoretically theoretically and MLSC equalizer having the best maximum probability yields, that the among the those who already get affected by the distortion propagations, and other means of specific environmental effects. So this MLSC yield the best possible performance performance, but is is computationally 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 intensive. Intensive. So in this equalizer, the training sequence training sequence is used to estimate the channel multipath multipath characteristics characteristics and then use the estimate estimate of the estimate of the channel channel to estimate the effect of inter-symbol interference. Effects of ISI so the computational complexity of an MLE increases so computational complexity of MLE increases with the increase of with the large number of this delay, larger delay spread and spread and and signal cancellation size. Constellation installation the number of number of state number of states of the Viterbi decoder so Viterbi decoder is implemented to estimate estimator basic estimator and the number of states of Viterbi decoder is expressed by the capital M expressed as कैपिटल एम ऊपर सफिक्स में एल है सो वेयर एम इज द m is the number of symbols is constellation 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 after uh, these steps and L is so m is the number of symbols is constellation. L is the number of channel speed length. Channel speed length. So the block diagram of is just like decision feedback equalizer, but one block is additional added for the prediction for to get the maximum probability of this estimator. Receiver MLSE receiver is based on DFV is shown in the figure number 1. There is a match filter or all the received input is applied at the match filter y of t. This is the channel output. There is a switch. The match filter output is z of t coming at the switch. After it is depending on the state of the number of states, that is z of n. So here it is coming in MLSP, maximum likelihood sequence estimator. It having the two output. One is for the estimated data sequence having the value of a of n, and this MLSV maximum likelihood output is before passes to the channel estimator. It having the again two input. One is given to the to make a total sum of estimated and the coming from the channel uh, affected signals, get effective signals. Here we sum up here, take the difference between these two signals and the error of these signals is added is in the channel estimator or also given to the match filter to match all the possible optimal successful signals, those who are having the maximum probability are not having the any inter-symbol distortion. So we need a delay to take the estimation here. This is figure number 1. Block diagram of maximum likelihood. So in this block diagram, given the estimates of the discrete channel impulse response from here, and there is a maximum likely MLSV receiver. This is the MLSV receiver. It used the this uh, as a Viterbi algorithm, and it fit into the Viterbi algorithm to get the to obtain your maximum from here, to obtain a maximum likelihood estimate of the transmitted signals. So this is the uh, uh, signal uh, for the channel estimation. This output is affected either ISI or other distortion phenomena, that is phase, amplitude, and other reflection, diffractions, yeah, scatters. So this response is highly estimated by the channels because it passes through and is coming to the match filter, and given the estimate of this discrete channel impulse responses. This is the discrete impulse response, and here MSB receiver to taking the output of this match filter, and it's given to the your Viterbi decoder algorithm, and after the yield of this algorithm, uh, which is obtained the maximum likelihood estimates. The estimate are feeding from this side, from here, and it obtained the output of this Viterbi algorithms to at this sections at this point, and this estimates of is a for the transmitted symbols, because whatever the transmitter transmit the symbols or pulses, they are exactly coming at the receiver side. So we need to put a some sort of filters to eliminate eliminate this ISI from the sides of receiver before it goes to demodulate it and it converted in a original form of form of data. So it received the here it received a baseband. So the transmitter is a baseband linear linearly modulated linearly modulated signals modulated input signal, and important thing is the output of this maximum likelihood sequence estimator sequence estimate of the signal using the channel output of the using a output of an using an estimate of the channel modeled as a finite infinite input response response that is called FIR filter. So Viterbi so MLSV equalizer decodes the received signal first of all, or you can say firstly, by applying applying FIR FIR filter corresponding corresponding to the channel estimate to the symbols in the input input signal. Then then it gives the Viterbi algorithms to compute compute the trace back path and the state metric, which is are the numbers of assigned assigned to the symbols at each step of the vector V algorithm this matrices are based on Euclidean distance equal linear to the distance. Then the output of maximum likely estimate of the signal as a sequence of complex number corresponding to the cancellation points cancellation points of the modulated signal. So so at this point we are given the sample received signal in the form of y of t. This signal goes to the match filter, and by passing from MLSP to channel estimator through the channel estimator is the match filter and the delay. So under these sections where the our vector V is used, this is the two important block: maximum likely sequence estimator and channel estimator. The channel estimator consists of the match filter as well as delay. and the difference between is producing by here in the form of error, and it goes to the this maximum estimated form of data sequence, and where all this process are involved to detected the symbol, then it again goes to channel estimator. The sample impulse response of your channel from here taken at the two sample intervals, and it measured with the adaptive channel estimator. Then it's compare with the sequence of sample received signal with all possible received signal. So this sample is from here is passes to the this end, and here it is the match, or you can say compare, and then determine the most likelihood signals transmitted symbols. This is the optimal methods of cancelling the ISI. If the match sample signal is after removing the ISI and which are coming it are match, then there is cancellation process. If the difference is not in the form of error, then the receiver grows the exponentially, and it is working is a complexity because the length of the channel responses increases as increases the transmitted symbols. So today is only this much in this uh, topic.